Hello. So, welcome back to my channel, and in this video I'm going to show you hopefully how to set up a Waveshare LoRa interface device in the form of a Raspberry Pi hat, and it's going to be plugged onto a Raspberry Pi 4. I just got a Raspberry Pi 5 arrived in the post just a few minutes ago, so that'll be the subject of another video. But this is Raspberry Pi 4 we're going to be looking at. So the idea is to run Meshtastic software on the Raspberry Pi 4, and the hat will be the interface to the radio world, which I showed in the previous video, the short one with the flashing LEDs. So what I'm going to do now is to try to set up the software on the Raspberry Pi. And if we just look around on this website, this is from waveshare.com. This is the device I have, kindly provided by a friend who let me have one at a very reasonable price. This is the one with the GPS module. That's that chip there, which they don't all have. I don't know how necessary it is. It depends on what you want to do. This GNSS connector is for the GPS antenna, which you can leave off till you want to play with GPS. This is the SX1262 LoRa chip, which has a transmitter in it with an output power of, I think, 140 milliwatts plus 22 dBm. And for this reason, you should always connect an antenna or something to that connection. What I actually connect is a dummy load. It's actually an attenuator, but I connect a little 20 dB attenuator, which would give 40 dB return loss here. So it's a nice matched load to avoid destroying the chip when it tries to transmit for a period of time, probably. Anyway, just for the sake of safety. And what else is on here? There's some spec for the device. Choose the one for the frequency range in the country you are, which in UK and Europe is 868 megahertz. There's some information about that device. There's one thing to note, and that is it needs a battery here on the back side. This is for the ephemeris data backup for the GPS module, if that's important to you. And it's a rechargeable battery, so don't put a lithium-ion battery in there because the board will try to charge it, and that's not always a good idea. Risk of fire or explosion. So use a rechargeable battery. They're quite rare. I've forgotten the number. I think it was MP1222 or something like that. It's in the spec here, and you need to order those, and they seem to be hard to find and quite expensive unless you order them in China, where they're super cheap. Anyway, that's that. So what else do I want to look at? We need to set up a Raspberry Pi. So to do that, you need the Raspberry Pi imagers, the easier way. I'm doing this on Windows, by the way, because I think the majority of people are using Windows, maybe. And so I'm showing the Windows way of doing things. So this is the Raspberry Pi imager. And I'm not going to tell you how to set it all up in too much detail because there are plenty of videos about that. The operating system that I'm using is Raspberry Pi OS 64-bit, the latest version. So it's based on Debian version 12, codenamed Bookworm. That seems to work nicely. And it's important, I think, to have a fresh install and then set up the settings correctly, because I tried it on a less fresh install, which had been communicating with a chip programmer, and I thought it would work, and it didn't. I had to just give up and reinstall. That's one of these chip programmers, so that wasn't a good idea. So fresh and clean install is always the best because it's more likely to work. Having installed the required packages, the main one, of course, coming from Meshtastic themselves. If you look at their website, meshtastic.org/docs hardware devices Linux native hardware, they've released Meshtastic software to run on Linux native devices, not on these little boards like Heltex and Rex. So, and as you can see, the Raspberry Pi series are supported. I'm going to do it on a Pi 4. So also on the Pi 5, there's a note here because it's a little bit different. So I'll try that in a future video. So Raspberry Pi 4. And you just follow the instructions, which is what I did, and it didn't work, and then I had to do it again. So I thought I'd make this video just to try and condense this into a set of instructions that's easy to follow and works first time. And if you look at the link they give you to GitHub, this is where the software is stored, the firmware. Well, it's not really firmware, is it? It's software to install on the Raspberry Pi. And I use this version, which is the latest beta version that has this number of the Meshtastic software. There are various ways of getting it. You can just download it from here. And I did it the neat way, which was to use wget. And this is the file you need, Meshtastic D 2.3. Whatever, arm64.deb, and it's 41.2 megabytes. That's the the software that I've installed, and I just use the wget command. What you can do is you can right click on this and do copy link, and that gets the whole URL to that file, HTTPS, the whole thing to the file, and then you can use wget in Linux on the Pi to download it, which is what I'll do in just a few minutes. So that's all of that, and I'm manually switching stuff. So let's turn off the web browser and turn on the view of the Raspberry Pi installer. Just to show you, you do need one or two settings in here. You can see that you can edit settings on the Raspberry Pi installer. Let's look at that first. If I can find it, can't find it, so I give up. So you click Edit Settings, and what you get is a window like the one that I'm about to show you, when I can find it, which is this one. And what you have to do is set a few things. You have to give the Raspberry Pi a host name, and you need this later because this is going to be the URL you use to connect to the web interface to Meshtastic. So you need a host name, call it whatever you like. You need a username and a password, of course, so that you can log into the thing. I've got wireless LAN turned off because I use a Ethernet cable plugged in for stability. And I've also set up in my router the DHCP server to give a fixed IP address to this Raspberry Pi device so that I can find it quickly instead of a randomly allocated IP address, which is less easy. And what else have I done? Yeah, you can tell it what keyboard layout you want to do and language, of course. And under services, I've enabled SSH because that allows me to SSH into the Raspberry Pi device. I'm actually going to set it up as a headless server without a keyboard and a monitor plugged in. So you can just go in via the network connection from another computer, which is this Windows computer I'm recording this video on. So we're going to use that method of going in via SSH from the terminal. Options, what are they? Oh, that's about writing the card. So you flash the tiny micro SD card. Here's one. And that takes quite a long time. So it's best not to try to watch it doing it because it takes forever. Go away and do something else. So that's that. And then what I'm going to show you next is the terminal. This is the Windows terminal. And I think you can start it on Windows where you press the Windows key, whatever it is on the keyboard, and just type terminal, and you find this program. It used to be called command.exe. Who knows? So this is the Windows terminal. And as you can see, I've played with it a little bit already. Here's the SSH command. I'll try and paste the various commands into the description of this video so it'll make it easier to follow. So you SSH to the username you set for the Raspberry Pi at the IP address of the Pi. And the first time I did it, I got this error because the key, the private key for the encryption of the SSH had changed because I reinstalled the software on the Raspberry Pi. And every time you reinstall, you get a new private key generated. And Windows stores the private key for that IP address. And of course, it's different. So it looks like a man-in-the-middle attack is taking place. What you have to do to fix this on Windows is you go into this file here, known hosts, which is probably a hidden file and a hidden directory if it starts with a dot. So you have to turn on show hidden directories. Find under your username on your Windows the .ssh file that has a list of all of the IP addresses and the private keys for them. And just delete the line for this IP address set for the Raspberry Pi, so that when you try to connect to it, it will it'll work. It'll actually say, oh, this is an unknown device. Are you sure you want to connect? Because it's not in the keys list. You just type yes, press enter, and then it will allow you to connect. And first thing I do is always to do a sudo apt update and sudo apt upgrade, which I'm not going to show you because this really takes forever. So you type sudo apt update to update the packages list, and then upgrade. And because it's a fresh install, there's a lot of packages to install. Probably says how many, 123. And even with a fast internet connection, it takes a while because of the slowness of the Pi. So it goes, shows you what it's doing, tra-la-la, to update the software, the operating system, to the latest version, which is always a good idea to start with. And as you can see, it took a long time. So, and then it's a good idea to reboot. You need to do sudo reboot because you're not root on this little device. So then it reboots. So what I'm going to do now is connect again and see if it works. And this is one of those famous things where things don't always work, but I think it will. Enter the password. Can I remember it? Never use the same password twice anywhere, of course. there it is. So we're logged in. As you can see, we're logged into this little Raspberry Pi device via SSH, via the Ethernet connection on the network in the room where I am. So there we are, we're logged in. And the question is, what do we want to do first? I can't remember, so I'm going to look at my notes, which is, who remembers Blue Peter? Here's one I prepared earlier, and you can't see my notes because it's too many windows to switch. What do? Oh, I need to install these packages that are required by the Meshtastic software. So let's do that. So Control-C to copy them. And for Windows terminal to paste, you right-click, and the right mouse click or trackpad click pastes. So these packages are going to get installed. So let's do that. It shouldn't take too long because there are not too many of them. They're not too big. Do you want to continue? Yes is the default. So just press Enter. And it's installing those packages. And it might be a good idea to reboot after doing that, or maybe it won't. I'm not going to bother just yet. I'm going to, first of all, get the Meshtastic software, but not install it yet. And you have to install those packages before you install the Meshtastic software. Otherwise, it looks like it's installed, but it doesn't work. I had that problem earlier. So let's copy the get the software link and paste that into the terminal. It has finished, so right-click to paste. So that's going to wget the Meshtastic software, which is 40-something megabytes. There it is, 41 megabytes downloaded. And it's put it in a directory called Meshtastic, and then the version number, whatever that is, which is actually, if I do ls-al, it will list, there it is, it's the red one. They made it red for me. So that's the directory that software just went into. You need to set up some hardware configuration on the Raspberry Pi, and I'm going to do it using a script that I got from their website because it's guaranteed to work better than manually editing. What we can do is look at the file that's going to have some settings changed. It's called config.txt. So if I do, what's right click, isn't it? I'm used to Linux, which is Control-Shift paste, Control-Shift-V. So this is the just looking into that file without editing it, the config.txt file. And you see there are various parameters which are currently turned off because there's a hash sign in front, which means they're disabled. You can just delete those and then they will be enabled, but I want to make sure I get this right because they have to be in the correct sequence. If they're not, then things start to go wrong. And there's another one that needs to be added at the end. So that'll come soon. Actually, I'm going to do it now. So what we're going to do is copy and paste in these commands that I've already got written to make those changes in that file. So Control-C and then right-click. Here comes the first one. So it's going to set this SPI to on. And then I'm going to go and get the next one, which is going to turn on the I2C, although people call it I2C because that's what they read. But it's, yeah. So that was the first one. This is the second one. Right-click. I'll get used to this one day. That's done. So it's making those changes in the config.txt file. It's turned on the I2C arm to on. And then you have to do something a bit tricky, which is put something in the right place depending on what else is there. So this is done with a little bash script like this. So that one goes in. Oh, not Control-Shift-V. I've got it wrong already. There it is. So that's putting in this thing, dtoverlay equals that. And then the last one, I think, is to, oh yeah, this has got an if. If something's not there, then put it there. So another bash script, Control-C, Tab, right-click, dunk. So if not that, then do this. So it's hopefully done it. And is there anything else I need to put in there? Oh yeah, we have to enable the serial port. If there's a GPS chip on the hat that you've got and you want to use it, you need to enable the serial port. The UART has to be set to 1 to enable that. So let's do that just in case. Control-C, right-click, enter. Let's put a few more enters in to move that up the screen. So that's turned on the serial port UART, and you have to disable serial console. Otherwise it might clash. So that's this one. Control-C or Tab, right-click, that's that one. So that's disabled serial console. So that should be everything. Yes. So what I need to do now is to reboot. What we can have quick look at is to see if those changes have been made in that config.txt file. So let's do that. Move up. So this is the file, and oh yeah, at the end, enable UART equals 1. So let's turn on the UART. That worked. It's probably quicker to do it manually, but when I did it, I got it in the wrong sequence. So I've done it this way instead. You can see it's turned these three on. That one's been left off, and then it should have added in another one somewhere. Anyway, let's assume it's correct, because I'm sure it is. So now I need to reboot, which you do with sudo reboot, like this. And of course, the Raspberry Pi is rebooting. It's broken the SSH connection, and so we're back in Windows Terminal. I have to wait for it to reboot before I can reconnect. I don't know how long that will take. Is there something else we can do while we're waiting? Yeah, we will see. So I'm waiting for my Raspberry Pi to reboot. I could fast forward, but I'm too lazy to edit videos. Perhaps you can write something in the comments about your Meshtastic experience, like what you've managed to do, and what kind of contacts you made and how the mesh is building up in your area. And this Raspberry Pi hat actually is useful because it gives you a web interface that can be accessed via a web browser, as we're going to see. You can also have the web browser running on the Raspberry Pi itself. If you've got a keyboard and mouse plugged into it, then you can use it as like a Meshtastic terminal. I find the functionality is a bit limited on the web interface compared to using a mobile phone with the Bluetooth connected to the Meshtastic app on the phone. You can do more with it. For example, traceroute is missing, and I do traceroute quite a lot for testing things, and as far as I can see on the web interface on the web browser, there's no traceroute command possible. Hopefully someone will correct me in the comments below, because I haven't found it yet and I would like to have it. So let's see if this is rebooted yet. So SSH into there. Oh, it has. Password. So if you talk long enough, anything's possible. So it's rebooted and it's running. Very nice. Of course, it might not have started up all the services because the Raspberry Pi 4 is not as fast as the 5, as we'll see later. So what am I going to do now? I'm going to look at my notes and find out what I need to do. We check the config.txt file was okay. Oh, that's interesting. Just to make sure the UART's working, I can look for, what's it called? TTYS0 is a device, which will be the UART for the GPS device. So let's have a look at that. See if it's present. Right click. So using dmessage and grep. Yeah, there, sure enough, we've got a serial device called TTYS0, and that's the connection to the GPS chip. So it looks like that worked. Good. Hopefully all the others work too. So what do I want to do next? Oh, I'm going to install the Meshtastic software now. I'm not sure. I think I'm going to have to change directories into that. Let's try it without first and see what happens. So let's right click. Bing. Oh no, it's working. I didn't have to cd into the directory. So you type in this command, this sudo apt install /meshtastic deb file, and it's installing and it's working, and at the end you see the error says permission denied, but that doesn't matter because all it's done is it's done an unsandboxed install, which may not be quite so good for security reasons, but and the reason was because the permission was denied to do that, but it doesn't matter, it'll run. So that's probably working. This is the exciting part now to see what's going on. So having installed it, we have to first of all edit the config.yaml file so that we can put in a few settings that are required. And this YAML file is read by the software as it starts up. So let's do that. Right click, enter. So this is the config.yaml file, which is stored in that Meshtastic D directory, which has been created by the install. So what we have to do is I can already remember what to do. Make a few changes here. You have to choose which LoRa hardware you've got, and it happens to be the first one. This Waveshare SX1262 in my case is there. So you have to uncomment. Make sure you do really uncomment, especially the first one. I forgot once. So you really have to uncomment those lines to set up the IRQ and different settings for that particular device. Don't delete any of these spaces in between or try to tidy up this YAML file because it's very sensitive to spaces. So it's best to leave it alone. So I've done that. So I've uncommented those lines for that particular hardware. You have to uncomment the serial path line if you want to use GPS. So I need to find the serial path line wherever that is. and uncomment it. And you'll see now how tricky it is to do these things and how to find things. I've probably gone past it as usual. Oh, here we are. GPS serial path equals, oh, that's the one, dev ttys0. So we delete the hash to make it uncommented, so it's actually present in the file to be executed or seen. So uncomment 0. Check required log level. Oh yeah, the log level setting I like to change, and also the web server lines have to be uncommented because we want to use the web server. So going back to this YAML file, you have to use the cursor keys to move through it. You can't just drag things up and down. Somewhere down here, actually I know it's near the end, so let's skip to the end. Max nodes is 200. That's the maximum number of nodes that can be stored in the node list. You can change that up to thousands apparently. Oh, the web server, we want that to work, so let's uncomment that. Port 443, so it's an HTTPS connection only, and that's the directory where the web server pages are stored. And then log level, this is for showing output in real time on the console of what's going on. And info is nice, but I want to see everything. So I'm going to change that to debug, which will show me absolutely everything that's happening. It's quite useful, especially when things aren't working, because then you can see what the problem is. So log level is debug. Now we need to save this. So I'm just going to do Control-X to exit. And you want to save it? Yes. Y for yes, and where to? That YAML file. So there it is. It's done. So hopefully everything's now set up, and I could actually start the program and see what happens. So let's just do that using the command that I'm about to paste in there. Control-C, Alt-Tab. So move up a bit, do a right-click. Ta-da! So this enable Meshtastic D now should start the program running. And I want to know if it's running, of course. So let's get hold of the command to look at the logging data output that I was talking about. Debug output, Control-C, tab, right-click, enter. Oh, it looks like it's running. So this is the debug output in real time, which is being sent via the network and the SSH connection to the terminal on Windows, and you can see stuff is happening. Of course, it takes time to start up and set things up and get things running, but it looks like I'm not seeing any fatal errors. These times get filled in later on. Yeah, this looks healthy. Oh, frequency 906, that's wrong. Ah, that's because I haven't actually set up any of the radio settings yet, which we have to do with the web server. So it may be time to switch to the web browser and to actually make those settings. So what I'm going to do now is go back to my web browser, which is there, and I'm going to turn off the terminal for a bit. And let's go and have a look at that web browser. Those are my notes I was using. So now we'll look at this URL. Remember the Raspberry Pi needed a host name. I called it Raspi, or Raspi. There it is, Control-C. So let's put that into the browser. And you have to use a Chrome-based browser like Chrome or Chromium or Microsoft Edge. It's also Chrome-based. They don't advertise that too well. Anyway, so that's the URL. Press enter. Let's see what happens. Oh, it worked. You always get this when you run your own servers if you haven't set up private keys and certificates. So isn't private? Well, it is. It's encrypted, but the key is not a recognized one. So you say continue to Raspi unsafe. There it is. Ka-ching. So that is now the Meshtastic interface served up via HTTP to a web browser on another computer in the network, or it could be on the Raspberry Pi if you put localhost in there. Or yeah, just Raspi will probably find it. So this is the web interface to the Meshtastic software running on a Raspberry Pi. So we've got a new connection we want to set up. It's an HTTP connection this time. It's not Bluetooth to a phone, and it's not serial via USB, which is the old way. I used to do it, and for flashing firmware onto Meshtastic nodes. So we're going to use HTTP. The host name is Raspi. Use TLS, so it's encrypted just in case. And there it is. And first thing to do is to go to config to configure the device. And the first thing I like to do is set up the frequency range. So in the LoRa settings, region is currently unset. Let's change that to EU868, 3 hops. All the other settings you can leave as default, or ignore MQTT. Let's turn that on just in case somebody is spraying MQTT data into the radio network. Everything else is fine. Transmit enabled. And then you have to hit save, which is up here on the web interface. Who remembers 3.5-inch floppy disks? So it's saving, and what that means is it's also going to reboot or restart the software. So that takes a little bit of time, as you probably know if you've used these other Node devices, and there's not much difference here with the Raspberry Pi version. So hopefully it is rebooting. And what else can we do? That's radio config. Device. Oh yeah, it's got a name, 48A9. I'm going to leave the short name and long name as that. You can edit those and change them to something more sensible, but I'll just leave it like that for the purpose of testing. Position means location to me, and that's switched on. I haven't turned on the GPS yet. I haven't plugged in an antenna. Everything else we don't have to worry about. So nodes. Are there any nodes? No, I haven't seen any yet, but it takes a time to build up the list of nodes. Let's go back to config, module config. They mean software modules, not the hardware modules. MQTT is not enabled. Good. All these other things don't really matter so much. Neighbor info, I like to turn that on normally. So it talks about the neighbors in the mesh to help build up the mesh. I also turn on the range test enabled with a setting of 0 to stop it putting out those sequence numbers for testing. Seems to help with the traceroute command. Anyway, that seems to be running. And messages, primary channel is long fast. Let me make that smaller so that I can actually see it. Well, that doesn't work, does it? All right, make it bigger so I can see it. Interesting. Never mind. I'm not sure if it's actually really connected to any nodes yet. What I'll try to do is to send it a message via my other Meshtastic node here. So I'll just send something in long fast. I'll send hello. And it may or may not work. But anyway, that's the showing you the setup. What I'll do is I'll make another video showing the thing working. But at least I've shown you how to set up the software, and hopefully everything will be running nicely. What I can do is have a quick look at the debug output. Check on that by going to terminal, turn off the web browser, and looking in there. Yeah, it's doing stuff. It's probably still starting up. And it's received a packet from somewhere. That's a good sign. Yeah, so there's activity, radio activity going on. So it looks like it's working. And it's just going to take some time for something to happen. I'm just checking on the Meshtastic app here. So hello has gone into the long fast channel. It's got a check mark in the cloud, and not sure if it's actually been received yet on this device. Might take a little bit longer. Anyway, I'm going to leave it there, and we'll come back to this when I'm sure that it's all working, because so far that hello message has not appeared in here. Thanks for watching. Remember to like and subscribe, and the fun continues.